is to be prepared. Before each welding, you must ensure that the long-life crucible doesn't contain any moisture. Porosity in the weld would result. Thus, dry the crucible uniformly by a soft torch flame inside until the outside of the crucible has reached a temperature of at least 100 degrees Celsius. Insert the clean magnetic end of the applicator into the metal sleeve and close the thimble opening of the long-life crucible by the thimble. Distribute the plugging sand evenly around the tapping thimble. No plugging sand and no foreign body are to be within the metal sleeve. Now lift the applicator vertically and fill in the welding portion. Before filling in the thermit portion, the inside and outside of the crucible should be checked for damage. No sand residues or foreign bodies shall be inside on the tapping thimble. In opposite to the long-life crucible, the single-use crucible need not be dried before using. It should be kept dry and closed. The thermit portion, which is accordingly selected to the code of practice, is to be filled in the single-use crucible. Moist portions must not be used, even if they've been dried. Undamaged portion bags shall only be used. Porosity in the weld would result. The preheating torch, as well as the cutting torch, work according to the injector principle. Therefore, here is also to be lit in the correct order. First, open the oxygen valve fully, and then open the combustion valve only a little bit. Then light. Set the torch flame only at the combustion valve, so that the inner flame cones have a length of approximately 20 millimeters. The later closing of the torch will go in the opposite order. First, close the combustion valve and then the oxygen valve. Whilst an improper flashback of the flame into the torch happens, the oxygen valve as well as the combustion valve shall quickly be closed. Moist slag pans are to be dried to avoid a dangerous creation of detonating oxyhydrogen gas during the later slag running in. The burner saddle with inserted torch is set up. Then it shall be fixed and adjusted. The oxygen valve on the handle shall fully be opened. Now, by slightly opening the combustion valve on the handle, install a combustion excess in the flame. The torch flame develops a rattling noise. Then close the combustion valve at the handle so far, only until this rattling noise just disappears. Therefore, an improper oxygen excess is excluded in the flame. The preheating runs by neutral flame. Both flame cores over the molds should have the same length as well as the correct height. Only now starts the preheating time given in Code of Practice. The simulation shows how to heat up both rail ends. The lighter the colour, the higher the temperature. With the aid of removing of one mould half here, it is viewable how the preheating flame equably heats the complete cross-section areas of both rail ends. Now you may distinguish the necessity of an exact adjustment of the torch centrally over the gap. The working pressures whilst preheating differ according to the welding processes as well as to the gases and are given in the Code of Practice. The working pressures are flow pressures and therefore they're to set only whilst the flame is burning. At site, the gas is to extract from cylinders. When the gas extraction takes longer, then the cylinder pressure decreases. In consequence of the working principle of the reductor, the working pressure inside the hose lightly increases. Thus, the working pressures shall be kept constant during the whole preheating by regulating the reductors to avoid any subtly uprising of oxygen excess in the preheating flame. Depending on the welding process, the finish of preheating is determined either by succession of a time or by reaching a temperature of 900 to 1000 degrees. That is according to a yellow-red colour. It is to check visually. When preheating using compressed air and gasoline, then the setting of a stable blue preheating flame is very eminent. Finishing the preheating, the torch is to be removed. Now the temperature of the rail ends slightly decreases, therefore the next step shall go rapidly. Then the plug is to set into the moulds. The plug diverts the pouring stream and prevents the slag, which follows the outrunning steel, will directly dip into the bath of liquid steel. Different solidification temperatures of steel and slag are the reason for this. The crucible is to be placed onto the moulds. The igniter is ignited by the torch flame and is then plugged for 2/3 of its length into the thermit portion. The reaction produces on the one hand liquid steel, which is heavier and founds to the bottom of the crucible, and on the other hand liquid slag, which is lighter and rises up in the crucible. After the segregation of steel and slag, the thimble melts through. First the steel pours in, then the slag follows and fills the slag pans. Once again, the pouring is shown as a simulation. The poured liquid steel cools down and solidifies slowly. The appropriate form design of the casting mould determines the three-dimensional cooling and solidifying procedure. The result is a weld material without inner failures and with requested properties. The empty crucible and the slag pans are to be removed and to place on dry and non-flammable ground. Attention! If hot slag contacts moisture, then oxyhydrogen gas explosively generates. Danger of accident. The protection of the railheads is taken off. Now the clamping device and then the mould shoes are to be removed carefully. A specified waiting time after pouring should be kept for this. Predetermined breaking points on the moulds are to be created. After another waiting time after pouring, the mould head, including the slag, is put off. The running surface is to be cleaned of all residues. A hydraulic trimmer is used to cut the excess metal from the weld. The cutting height over the running surface is limited due to the down holders. If the mould head is removed early, the welding material is coloured white or light yellow. Start the trimming when a darkening by oxide skin with blisters rises up. If the mould head is removed later, the welding material is already coloured yellow. Then immediately start the trimming. The given waiting times after pouring to the mould head removal and to the beginning of trimming may be only rough recommendations. Influences on the waiting times are the rail temperature, the used crucible system, the gap width, a different wear of the railhead, the matched preheating gases, an incorrectly set flame with oxygen excess and incorrect preheating time, an incorrect preheating time, as well as specific portion grades. All these facts will be imparted during the welder's training. The cooling down rate shall not be too high because of its influence on the welding material's properties. Therefore, it is necessary to cover the weld during rain and wind to defend it from quick cooling. The rails get shorter at decreasing temperatures, so unacceptable tension forces appear onto the solidifying welding material. To counteract this unacceptable rail movement caused by shortening at decreasing temperatures, either you heat the rails or you hold the rails by hydraulic puller devices. The residual welding material on the running surface and on running flank will be grinded off. The shrinkage downwards is finished not before the ambient temperature is reached. Therefore, a small oversize has to remain after rough grinding. In case of reassembled and tightened fasteners, the weld could now be passed by a running wheel. Only when the weld is completely cold can you remove the mould residues and knock off the risers at the rail foot. The shrinkage is finished and the fasteners are reassembled and tightened. Only now the final fine grinding has to be executed. By means of fine grinding, the railhead profile at the running surface, at the head radius, and at the running flank is to be restored. The compliance with the demanded tolerance is normally checked by the 1 metre straight edge and by the filler gauges at the running flank and at the running surface. The weld is to be marked. And this way, a complete thermit weld looks at a Vignal rail, at a grooved rail, or at a crane rail.